Hello. So I was going to start going over the basic instructions of the final, um, when it'll be available, the basic, how many questions, all that jazz, as well as a little bit about the plan for tomorrow and Friday for consultation days. Then we can go over any questions that you have. So I'll start with just the final itself. So that will be available all of finals week. That is December 11th, next Monday, to December 14th, next Thursday. You'll have all 4 days to take the final, and I'll also post an announcement when I have, so you guys know when it's available to you. Then you can know, okay, I can get started on it right now, or I know it's up, whatever the case may be. So as far as the final itself is concerned, you will have, like I said, 4 days to do it. You have it has the same structure as before, 50 questions, all of which are multiple choice. You'll have one attempt, and that one attempt is going to be an hour and 50 minutes, or more if you require additional accommodations in regards to time. The plan for tomorrow and Friday, so Thursday and Friday, the 7th and the 8th, are consultation days across the board. So if you have any in-person classes at state, you'll know that there are no classes on Thursday and Friday. That is because those 2 days are meant for you guys as students to come meet with your professors, ask any questions or get clarification, or whatever you need to meet with your professors for. That's what tomorrow and Friday are for. As far as how I'm running my consultation days, I don't have I'm not going to post a Zoom that people can just drop in and out of all day, because then I'd be there for 12 hours. I want to have a little bit of um, well, I'm not going to sit at a computer screen for 12 hours for people who I'm not sure if are going to show up or not. So if you want to schedule a consultation meeting with me, you are more than welcome to. Just make sure to message me or email me saying, hey, I want to meet at, Friday at noon, or, whatever fits with your schedule. I'm should be relatively flexible with, just so long as another student, one of my other students, I have about 100 additional students on top of you guys. As long as none of those students have scheduled a time before you did, I'm open. So I don't have any classes Thursday and Friday. So if you want to meet with me, schedule a meeting with me sooner rather than later, so another student doesn't take the spot that fits best for you. Let's see. Well, that is my chit chat on the final and the consultation days. So like I said, final will be posted next Monday. I'll post an announcement saying when it's officially live, and you'll have until December 14th at 11:59 p.m. to complete it. Now, with all of that being said, do you have any questions in regards to the study guide? What topics do you want me to go over? Any questions that you have, clarification, what have you? What do you need? Oh, okay. Um, well, in that case, I'll just kind of briefly go over bits on the study guide, and then I'll probably conclude the meeting. So, all right, so what you should know: when to use the basic inferential test that we've covered. So this is going to be, some questions might be similar to how we've had on activity 7, I believe, where you're provided an explanation, and based on the what's going on in that study, in that particular experiment, or what have you, it'll be you'll be tasked to choose which inferential test works best. So previous activities will really be beneficial for that. The characteristics of those tests, a big part of that is, what do these tests conclude? So not all of them are just saying, oh, there's a significant difference between the two groups. That's not the case for something like, let's say, linear regression. Linear regression is about finding differences between two groups. It's looking at how one variable is how accurately one variable can predict another's. So make sure that you recognize the differences in what these tests are doing, because like I said, not all of them are just significant difference. That's only for our Z tests and our T tests, and a bit of ANOVA as well, but correlation and linear regression, not so much. So how to determine statistical significance through p-values and test statistics. So keep in mind that p-value in alpha and test statistics and critical values are two different ways, two different pairs of information that you need to determine significance. Now, you don't have to have, you don't necessarily have to use both p-value with alpha and a test statistic with critical values to determine statistical significance to make your decision regarding the null hypothesis. You can have one or the other, but I want you guys to be able to know how to both determine statistical significance, which essentially just means you've rejected the null hypothesis, and then knowing whether to reject or retain the null. So these two are very similar, but just knowing that the big difference is knowing that having statistical significance is when you reject the null, and when you do not have statistical significance, that is when you have retained the null. That is what it is referred to when you retain the null. But as far as p-value and alpha is concerned, keep in mind that alpha is our limbo bar. And if we are significant at limbo in real life, if you are significant at the game of limbo, you can get under the bar, no problem, every time. You're significant. You're good at the damn thing. P-values work the same. If alpha, which is typically set at 5% or 0.05, as we've had it in this class, that's our limbo bar. And to have significance, to be statistically significant, to reject the null, our p-value needs to go under that limbo bar of alpha. So it needs to be under 0.05 as opposed to over it. If we are over the bar, if we can't get under it, obviously we're not winning any rounds of limbo. We are not significant as far as our limbo skills are concerned. So with that being said, it kind of bleeds into, well, when p-values are greater than alpha, they also do not have statistical significance, or we would be retaining the null hypothesis. Now, test statistics paired with critical values, we've done that a lot for our inferential tests, especially in our 4-step process when we've gotten to step 3 of calculating that test statistics. So be it Z tests or T tests or ANOVA or correlation or anything. We have our test statistic that we have calculated using our formulas, the step-by-step process, la-di-da-da. And then we have our critical values, which we actually establish in step 2 of setting the criteria. At what point do we say, all right, if our test statistic, if our step 3 calculation is greater than the positive critical value, or if we have a negative test statistic, at what negative point do we need to be below to have statistical significance, to reject the null hypothesis? So with that, again, if we have our critical values of, let's say, plus minus 2, that's easy to remember. 2 is an easy number for me to remember. So if we have a critical value of plus minus 2, that means any time we calculate our test statistic, when we calculate our test statistic, if it is a positive number, it needs to be greater than positive 2 to reject the null, to have statistical significance. Or it needs to be less than, if it's a negative critical value, if it's a negative test statistic that we've calculated in step 3, that negative test statistic needs to be less than negative 2, the negative counterpart of our critical value, in order for us to reject the null. If our test statistic is anywhere between positive 2 and negative 2, negative 1.19, positive 0.5, 0, 1.9, anything between positive and negative 2, we would be retaining the null. There would be no statistical significance. Okay, so the difference between categorical and quantitative variables, well, categorical variables are very black and white, all or nothing. It is, you are fitting into groups. So if you think of something like hair color or eye color, those are both categorical variables. We are finding we're to measure that, we are counting essentially. I can count how many people have brown eyes, have blue eyes, have green eyes in the class. I can count how many people have brown hair, maybe black hair, blonde hair, red hair, you know, other in terms of maybe not as natural colors, but you know, we tend to dye our hair fun colors because damn it, we can. So we can have people fit into these clear categories. It is all or nothing. I kind of have, I don't know, I used to have really blonde hair as a kid. Now I guess it's brown-ish. I don't really know how I would categorize my hair color. But I would say honestly, you know, it's pretty close to brown, so I'm gonna go with brown. Now, if I'm like, well, it's got brown and it's got some blonde highlights and it also has a little bit of red in it, so I'm gonna check my box for all three of those. Well, that doesn't really work because by me checking the box of three different hair colors, brown, blonde, and red, because I got a little bit of all three in my hair color, that's not, the data isn't showing, oh, that's one person with a combination of these three hair colors, but rather those are three different people. One person saying they have red hair, one person saying they have brown, and another person saying that they have blonde. So instead of one person having more complicated hair color, it is three separate people with three separate hair colors. Categorical variables, again, they are all or nothing. You can't kind of put a little bit in each box and say this is me. Rather, oftentimes categorical variables, when you do have that circumstance of kind of having a little bit of all of them, or special circumstances, or whatever the situation arises, oftentimes categorical variables have that option of other, which is kind of crappy because it does kind of other people. But in the sense of the data, it's like, well, I'm a little bit of all of these, but I am not 100% any one of them. So I'm kind of, I don't quite fit into these categories that you've provided me. Imagine, for example, if you are major, think about the major that you have. You know, a lot of us are psychology majors or biology majors, but let's say you're a double major. Let's say that you are majoring in both psychology and biology. Well, technically, if I'm asking how many, like, what is your major? Again, if you mark the psychology and the biology field, that's saying, oh, well, I am two different people. One person is a psych major, the other person is a bio major. But in the case of double majors, unless it specifically has a category, a group that says double major, you'd likely be categorized as other, just because you don't 100% fit in any one of those categories. Now, where categorical variables are very black and white, all or nothing, quantitative variables have a little more wiggle room. Quantitative variables are typically measured quantitatively using numbers. So my quick and dirty explanation is, hey, I can find the average of it. I can find the average and the standard deviation of age if I were to ask you all to provide me how old you were, you know, typically in years. So 18, 19, 20, 55, whatever, however old you are, you provide that to me, and I can find the average and the standard deviation of your ages. Easy peasy. Same thing for, oh, I'm going to provide you like a self-esteem survey or a depression inventory or any sort of measure, and it's going to be on a 1 to 5 scale. There's going to be 20 questions. All of those questions, you're going to be responding on a 1 to 5 scale, from strongly agree to strongly disagree, something like that. Well, I could analyze your data quantitatively. I can translate your strongly agree to a 1 or a 5, or however I want to do that. But I can kind of translate your responses to numbers, and I can find, by taking your average responses across those 20 questions on self-esteem or depression inventory or personality, whatever it might be, I can find your average self-esteem score by taking the average of all 20 of your responses and saying, hey, you have a self-esteem score of like 4.1 or whatever. So as far as those quantitative variables are concerned, well, Likert scales, that 1 to 5, 1 to 7, 0 to 4, Likert scales are pretty, the number itself doesn't matter so much for Likert scales, just that is representing a particular value, a particular concept. But that is still a quantitative variable. I can find the average of your scores. I can find the average across the entire class's averages. So quantitative variables are very much just how is something being measured? And can I find the average of it? Is it you measured using numbers? And would it make sense for me to find the average of those numbers? Okay. So now interpreting Cohen's D and Pearson's R, both of them have direction and strength involved. And when I say thresholds, I'm referring to just the strength threshold. So at what point is Pearson's R considered weak, considered medium, considered strong, and the same for Cohen's D. So that's what I mean by those thresholds there. So of course we know that Cohen's D and Pearson's R have slightly different strength thresholds. We know that for Pearson's R, the threshold's a little smaller, set a little lower, where anything but underneath 0.1 is considered weak, anything between 0.1 and 0.5 is considered medium, and anything 0.5 up to 1, because Pearson's R can only go as high as 1 or as low as -1. Anything 0.5 up to 1 is considered strong or large, whatever. Cohen's D, those strength thresholds are, again, they're a little higher. So for Cohen's D, we have anything below 0.2 is considered weak. Anything between 0.2 and 0.8 is considered medium. And then anything 0.8 and above is considered strong. Cohen's D does not have that same restriction in terms of how large it can be. Again, Pearson's R can only be as low as -1. That's a perfect negative correlation, and can only be as high as +1, which is a perfect positive correlation. You can't get any more perfect than perfect. So Pearson's R has those hard limits to how high or how low it can be. Cohen's D doesn't. Cohen's D is essentially just a measure of how many average or pooled standard deviations separate our two groups. So that can be a large amount, that can be a tiny amount, but it doesn't necessarily stop at 1 or -1 like Pearson's R does. So we have these different strength thresholds. Now we have direction. Now it's also important to note when it comes to strength and direction that these two things do not influence one another. So just because we have a negative direction for Cohen's D or Pearson's R, that will not change the strength of that effect size. That will not change the strength of that Cohen's D or of that Pearson's R. So a -0.85 Cohen's D has the exact same strength as a positive 0.85 Cohen's D. The direction, again, the positive or negative, does not have any impact on the strength. They will have the exact same strength as their reverse direction counterparts. So plus, minus, 0.5, 0.2, 0.7, 0.9, whatever. They're all going to have the same exact strength, regardless if that's a positive 0.2 or a negative 0.2, a positive 0.5 or a negative 0.5. And on and on and on. Now, when it comes to direction for Cohen's D, that doesn't tell us nearly as much about the variables as does Pearson's R. But for Cohen's D, essentially the direction, whether or not your value is positive or negative, really just depends on, well, we know that essentially Cohen's D is mean 1 minus mean 2, or population mean minus sample mean, or some means being subtracted from one another. Essentially, when we have a positive direction for Cohen's D, that just means the mean 1, the first mean that we did, was larger than the one that was being subtracted. And then if we have a negative direction for Cohen's D, that just means the small one was, oh my God. So that means the smaller mean came first and the bigger mean was being subtracted from it. It just was big. Did big come first or did the small one come first? That in a nutshell kind of boils down the direction for Cohen's D. However, for Pearson's R, this is not the case. For Pearson's R, the direction is talking about how the variables co-vary with one another. The direction in which the variables are traveling. So we're looking at two quantitative variables for Pearson's R. So when we have, let's say, a positive Pearson's R, regardless of strength, just the positive aspect, the direction of our Pearson's R value is positive. That means that our variables, our two quantitative variables, are moving in the same direction. So they both tend to be increasing together, or they both tend to be decreasing together. Both can be true. So we have a positive direction for Pearson's R is saying that our variables are moving in the same direction. A negative Pearson's R, if we have any negative value calculated for Pearson's R, this means that our variables are actually traveling in opposite directions. So as one variable tends to increase, the other variable tends to decrease. So again, they're just going opposite directions. So the direction for Pearson's R obviously gives us a lot more information regarding the pattern of the variables in our calculation as opposed to Cohen's d. Now, as far as interpreting Pearson's R and Cohen's d using a scatter plot or bar chart, I'm really more so focused on Pearson's R and interpreting scatter plots. So pretty much, I'm not going to give you super like hard questions for that one. It'll be fairly straightforward, or there will be options there that don't make any sense. So as long as you know that for looking at a scatter plot, if the values are increasing from left to right, so if they're just like, whoop, if they're doing that, if they are going from the left to the right and increasing as they go from that point, that is going to be a positive Pearson's R. As that line of best fit, that dotted line that's drawn to kind of be the closest to all of our points, if that is moving on an upward trajectory from left to right, you're looking at a positive Pearson's R value. And then the closer our points are to that line of best fit, the stronger the relationship. So we know the direction is based on if it's going up from left to right, that's a positive relationship. If it's going down from left to right, if it's kind of instead of going up, 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 if it's just sloping down from top to bottom, I should say, then that will be a negative Pearson's R. So now we know the direction looking at a scatter plot. Just look at that line of best fit. Is it going up or is it going down from left to right? Then the strength of the relationship will be really dictated on how close those points are to that line of best fit. Imagine a perfect positive or a perfect negative correlation. We have some scatter plots in our correlation PowerPoint to really emphasize this. But all of the points that are within that scatter plot for a perfect positive or a perfect negative correlation, all the plots perfectly line up with the line of best fit. There is no one outlier off to the side. No, it's the strongest correlation you can have, be it perfect negative or perfect positive. Both are the strongest you can have. And so all those points, all those data points perfectly line up with the line of best fit. You could just put a ruler down and draw right through it and you've hit all the points. So the stronger the relationship is, the closer our values are to being on that line of best fit. And then as far as the points kind of start to lose that clear pattern of following the line, I kind of refer to it as if you were to take like a shotgun or something. Now, I'm not really I don't own any shotguns in my life. But if you were to, let's say, like, or have paint on your fingers, you know, just dip your hand in paint and then just flick it at a wall or something, chances are you're not going to really have a clear, wow, I flicked paint and it all lined up perfectly in a line. How wonderful. Chances are that paint splatter is going to be very kind of all over the place. It's not going to have any clear linear pattern. So that would be a weak relationship. The more it looks just kind of like you just flicked it onto a board or something like that, the more likely it is that's a weak relationship. It doesn't follow that same as strong of a structure as we would for these stronger relationships. Okay. So next, what do measures of central tendency and variability tell us about a data set? So at this point, we should have we should be fairly familiar with mean, median, and mode, especially mean. We don't really use median and mode all that much. The only time we would use mode as the only measure of central tendency is when we have categorical variables. So I'm not going to find the median or the mean of brown hair in our class or brown eyes in our class. That doesn't make any sense. But the mode, as far as which of these groups has the most people in it, the mode, well, we can do that with categorical variables. I'm pretty sure that as far as hair and eye color are concerned, considering they're both dominant genes, I would say that brown would probably be the mode for hair color and for eye color. Just a hypothesis. But as far as what that tells you about a data set, again, mode tells you about the most, and they're oftenly used. They're more so solely used for categorical variables. And then quantitative variables can use mean and median. Quantitative can use mode as well, but it's often paired with mean or median. Now we use mean when we are assuming we have a normal distribution, and median when we have a skewed distribution of some sort. Finally, as far as variability is concerned, again, we have we have been working far more with variance and especially standard deviation than we had with range. Keep in mind that variance and standard deviation, since they're almost the same calculation, we just got to do that extra step for standard deviation. Again, we're standardizing it, bringing it back down to size by finding the square root. Well, with that, variance and standard deviation are really the best measures of variability because they take into account every point in the data set. When we think about range, all we got to do for range is take two values, the biggest and the smallest, and we subtract them. Big minus small, oh, we found our range, it's 7 or whatever the range would be. However, when it comes to variance and standard deviation, we're not just taking two values and leaving it at that. We are taking every single value, subtracting the mean from it, squaring that value, adding them together, dividing that by either the population or the sample size -1 or any variation thereof. But variance and standard deviation, again, it is a much better measure of variability because we are truly finding the variability of the entire data set, taking into account each point in that data set. Okay. So now the differences between experiments and correlational studies. So correlational studies, also known as non-experimental. Experiments we manipulate. I can flip a coin and I can say, hey, anyone who gets heads, I'm going to go down the roll sheet. I'm going to go down our roster, and for each person, I'm going to flip a coin and they're going to get either heads or tails. If they get heads, they get a study guide. If they get tails, they do not get a study guide. Simple as that. Heck yeah. Boom. Well, that would be an experiment. I am manipulating something. I am manipulating who does and who does not get a study guide. And then my dependent variable, what I think is going to be impacted by this manipulation. Well, what could impact study if you get or not get a study guide? Well, how well you do on the exam. So I'm going to compare the study guide, I'm going to compare your final exam scores between those people who received study guides and those people who did not, to see who did better. Now, that flipping a coin 50-50 chance for each person is a big part of what makes experiments. Now, for correlational studies, also known as non-experimental, that is saying I am not manipulating anything. I am not deciding who does and who doesn't get a study guide. I'm not even going into that. I am more observational learning. So I can kind of take a broad look at all classes who have had study guides versus all classes who haven't and kind of compare from there. I'm not manipulating anything there. I can also kind of straying away from the study guide example, looking at a non-experimental study. I can look at I can ask each and every single one of you, how many Instagram followers do you have? Some might have 0, some might have over 2, 3, 4,000. I don't know. But I can just simply ask, how many followers do you have right now on Instagram? I haven't manipulated that in any way. Obviously, I'm not sending bots your way to inflate your follower count. No, I'm not. I'm just asking how many you have. And then I can say, okay, take this self-esteem survey. I want to see if there's a relationship between how many followers we have on particular social media sites and our own view of our self-esteem, our own self-reported self-esteem. So I'm not manipulating that either. I'm just asking you, hey, fill out this self-esteem survey. But it's not like as I'm handing it out to you guys, like half of you, I'm flipping a coin and saying, ooh, heads, I'm going to give you a compliment when I hand you the survey. You're looking great today. And oh, you got tails, so I'm going to insult you. Wow, you're looking weird today. Like, you rolled out of bed like that? Like, absolutely not. So there is no manipulation there. I'm not anticipating, oh, I bet the people who got a compliment are going to have higher self-esteem scores because I complimented them in comparison to those who were insulted. I bet their self-esteem scores are going to be lower because I insulted them. I didn't do any of that. I'm just saying, hey, give me your follower count, let me know how many followers you have on Instagram, and then fill out the survey. And then I'm going to look into how those two things are related to one another, not cause one another. Again, correlation does not imply causation. So that's a big point to keep in mind. Finally, predicting variable outcomes from a linear regression equation. So we've gotten a lot of practice with this. We've gotten practice on the PowerPoint for linear regression. There were some examples on there. We've done it on our end class activity 10. I also believe on homework 11 it was on there. But essentially, for predicting variable outcomes from a linear regression equation, you will be given the value of X. So, we're using high school GPA to predict college GPA. This was the example that was found in the PowerPoint. Okay, well, I'm going to provide you a list of people. Well, I'm not going to say a list, but in that particular example, I provided you different people's high school GPA. That is our X variable, our predictor variable. We are using this to solve for Y, to predict for Y. So, all right, high school GPA, you plug in whatever that person's high school GPA is. And using that, now we can predict what their college GPA is. Again, Y equals BX plus A. Although, as we know, it's very similar to another formula, Y equals MX plus B. Oh, that sounds familiar. But ultimately, it's the same concept. We're given X and we just plug it into the formula, plug it into the equation, and then we solve for Y. So that is what I mean by predicting variable outcomes from a linear regression equation. I will give you X, and then you will provide me with Y. Simple as that. And also, very important, know that my cat's name is Petunia. Now, as far as the references, you can use different things you can use to study. Again, any homework that we have done, especially ones that are covering these topics, obviously, I've mentioned a lot of different slides. I've mentioned in-class activities. And then those cheat sheets that I have posted on Canvas is always going to be helpful as well, especially if you struggle with p-values and alpha and critical values and test statistics, knowing what to do, knowing what decision to make based on that. So knowing if you need to reject or retain the null, definitely refer to the null hypothesis cheat sheet on Canvas for like a little table to differentiate those. But that's all I have to say. So again, I'll post an announcement on Monday when the final exam is officially live. You will have until December 14th at 11:59 p.m. to complete it. You have, just like our previous two exams, you'll have one attempt with an hour and 50 minutes. So that has remained the same. The only difference is now you actually have all of finals week. So that's about 4 days, 3 days and some change, as opposed to exams over the course of the semester, which have been about 2 days and some change. So yeah, good luck to all of you. Again, if you need to meet with me for consultation days tomorrow or the 7th or the 8th, so this is December 7th and December 8th, those are Thursdays and Fridays, message me, email me. I'll be available unless another student has booked that time slot. I should have the availability. I've already have several people kind of scheduling in for some times. So just let me know when you're available if you do want to meet with me, and we can make that work. But until then, have a fabulous rest of your day. Good luck on not just my exam, but all of your exams. And I also like to say to all my students that you all deserve to be here in college. I know with online class, it can be kind of weird. We don't really have that much interaction other than, that I have this poster and I have my hats hanging here. Like, wow. But other than that, really not so much interaction face to face. So I just want you all to know that you all deserve to be here. I know it's easy to feel kind of like imposter syndrome in college where you feel like everyone else understands it or better than you do, or how did you kind of fluke your way into college, or like, I don't belong here, I'm not as smart as everyone else. That's a lie. Don't believe it. You do deserve to be here. You have done a multitude of things right to get you at the point you are right now. So keep believing in yourself, or at least know that that's the case. You can't continuously be foolish all your life and make it to where you are today. That doesn't happen. So you all deserve to be here. And no matter what happens in your life, strife, you know, difficult relationships, difficult family drama, whatever personal struggles you might have in your life, know that if you choose to get your education, whether you get a bachelor's, associate's, or even go further than that, know that that can never be taken away from you, no matter what hardship that you go through. So I appreciate every single one of you. And again, good luck on all your finals. And if you need to meet with me, just message me. Bye.